This is second part of video lecture for week 9. Here we study second derivative test. Note that second derivative test is to find local maximum, local minimum. So second derivative test uses the second derivative. If the second derivative is negative, then FC is local maximum. If the second derivative is positive, then Fc is local minimum. Note that this C is the critical number which we are finding by using the first derivative equating to 0 and solving. What happens if f double prime is 0 or f double prime is undefined? In these two cases, the second derivative test gives no conclusion, that means no result, that means this test fails. So when it fails, you cannot say that Fc is local maximum or local minimum. So we can say that Fc may be local maximum, may be local minimum, or may not be both. So this second derivative test fails whenever it is 0 and whenever it is not defined. So second derivative test works only for positive and negative. Let's take an example here. So one more important point here is that if the second derivative test fails, so we are not going to get any answer, no conclusion. So in that case, you go for the first derivative test and then conclude the result. Here, let's take an example, and for this we use the second derivative test to find the local extrema. Extrema means local, local minimum or local maximum. So first we find the critical number, that is C. So for that I find the derivative, then take 4x common, factorize this, then I will get T critical number 0, 2, minus 2, and then find the second derivative. So we have this. In this you substitute all these critical number one by one. See, I substituted. I get minus 16 less than 0, 32 greater than 0, 32 greater than 0. And then by this second derivative test, you see that f of 0 is a local maximum. That is, see this f of 0. F of 0 is a local maximum. That is, I put f of x is equal to 0 here. This gives me local maximum. F of minus 2 and 2 are positive. So therefore they are local minima. It is a plural word. So we have a one local maximum and two local minima. So this is how we find the use the second derivative test to find the local maximum and minimum. Let's take some more example and use the second derivative test for fx is equal to x cube, for gx is equal to x plus 1 to the power 4, and for hx is equal to minus x to the power 4. For a, find the derivative and the second derivative. This you equate to 0, gives you the critical number 0. Then put this 0 in this, f double prime 0 is 0. So since it is 0, so you cannot use the second derivative test. Then we have the second one, the first derivative and the second derivative equate to 0. You get one critical number minus 1. Put this in here. We have again 0. So look at it. Again, the second derivative test is inconclusive. So please use the word inconclusive whenever you have a 0. Finally, we have this, and the first derivative, second derivative, and equating to this to 0 and solving, we have one critical number. Substituting here, so again you have a 0, so it is neither positive nor negative. So again, so these are the three examples where the second derivative test is inclusive, but we cannot say that we cannot what you call draw the graph. I mean, you cannot test it. Yes, we can do the first derivative test and then find the what you call maxima or minima here. So this is the exercise on page 257. So here we determine the interval where graph of the function is concave up and concave down. So what you have to do, first you have to find the increasing intervals or decreasing interval, and then intervals of concave up and concave down for this example. And for this second one, here we are using the second derivative test to find the local extrema. These are the answers. What we have studied? We have studied what do you mean by concavity and how we use second derivative test to find the local maxima and local minima. Thank you.